In this video, we are going to discuss how to calculate the common speed of objects involved in inelastic collision. Question 7.60. A 1439 kilogram railroad car traveling at a speed of 12 meter per second strikes an identical car at rest. If the cars lock together as a result of the collision, what is their common speed afterward? So here we have two railroad car. We will call this as car 1, which is moving with a speed v1, and v1 is 12 meter per second. And the other car we will call it as 2, which is at rest, so its velocity is 0. Both cars are identical, so we can write for their masses as m1 equals m2 to be equal to m, which is 1439 kilogram. And after collision, they lock together. That means they stick to each other and move with a common speed v. We need to find this speed. Now, this is an example of inelastic collision, and we are going to use the law of conservation of momentum to find the value of v. We know from the law of conservation of momentum, momentum before collision has to be equal to momentum after collision. So momentum before collision is the sum of momentum of railroad car 1 and 2. So we write for car 1 as m1 times v1. Since car 2 is initially at rest, its momentum will be 0. After collision, they stick to each other and move with a common speed v. So we can write for their momentum as combined masses of m1 and m2 times their common speed v. I need to find what is v, so let's divide with m1 plus m2. So we get v to be equal to m v1. I'm writing the mass as m, as m1 and m2 both have the same mass, over m plus m, which will be equal to mv1 over 2 times m. Cancel off the m here. So we get the common speed v to be equal to v1 by 2. Velocity of car 1 before collision is 12 divided by 2. So the common speed after collision is 6 meter per second. Question 7.61. Bats are extremely adept at catching insects in mid-air. If a 50-gram bat flying in one direction at 8 meter per second catches a 5-gram insect flying in the opposite direction at 6 meter per second, what is the speed of the bat immediately after catching the insect? So here in this question, you have a bat, which I will call as B, which is moving with a speed we will call Vp of 8 meter per second in one direction. Let that be towards the right. So we write Vp as 8. Mass of the bat we will write as mb, which is 50 gram. We convert this to kilogram by dividing with 1000, which becomes 0.05 kilogram. And then you have an insect which is moving in the opposite direction. I will call this as I. And velocity of insect, since it is going opposite to bat, we will take it negative, which is 6 meter per second. So negative 6 meter per second. Mass of the insect will be mi, that is 5 gram, which we can write as 0.005 kilogram. And we need to find the speed of the bat after it catches the insect. So basically, we need to find their common speed after collision when they move together, which is v. Again, we apply the law of conservation of momentum. We know momentum before collision has to be equal to momentum after collision. Momentum before collision is the sum of momentum of the bat and the insect. So we write this as mass of bat into velocity of bat plus mass of insect into velocity of insect. Velocity of insect is negative. It is opposite to that of the bat. But we can substitute that value as negative later in our problem. The negative sign must be taken only once, either during the substitution or while writing the equation. If I take Vi negative for substitution, I don't need to put another negative sign here. So this is equal to final momentum. After the bat catches the insect, they move together. So we will write their masses together. Mass of the bat plus mass of the insect into the common speed V. We need to find what is this V, so let's divide by the mass here. We get V to be equal to mass of bat into velocity of bat plus mass of insect into velocity of insect over mv plus mi. Now let's substitute. Mass of the bat is 0.05, velocity of bat is 8, plus mass of insect is 0.005. Its velocity is negative, so negative 6 over mass of the bat again, which is 0.05, plus mass of the insect. And when you solve this, you get the speed of the bat after catching the insect to be equal to 6.727 meter per second, or you can round this off to 6.73 meter per second.